Hello, we are discussing about GATE 2005 ECE paper. The open loop transfer function of a unity feedback is given as g of s is equal to 3 into e power minus 2s by s into s plus 2. Find gain crossover frequency as well as phase crossover frequency in radians per second. Okay, we know that one gain crossover frequency at omega is equal to omega g. Magnitude of open loop transfer function g of s h of s is equal to 1. Okay, phase crossover frequency, when the input frequency is equal to phase crossover frequency, by the time phase of g of s h of s is equal to 180 degrees. Those are the definitions for the gain crossover and phase crossover frequencies. To calculate them, first we need to write g of s in terms of g of j omega. Okay, so first replace s with j omega for this g of s. So then it will be looks like g of j omega, s is replacing 3 into e power minus j 2 omega divided by j omega into j omega plus 2. This is what the transfer function in terms of omega. Okay, so first we need to write magnitude and phase equations for this one. And whenever we are going with magnitude, at that time magnitude of numerator consisting of e power minus j 2 omega. So if you assume e power j theta, the equation of e power j theta is cos theta plus j sin theta. Magnitude of e power j theta is equal to square root of cos square theta plus sin square theta, because a plus jb whole square is equal to square root of a square plus b square. So using that one you can write it as square root of cos square theta plus sin square theta, but we know cos square theta plus sin square theta is always 1, so this will be square root of 1. So the magnitude of e power j theta is equal to 1. It may be minus j theta also. If it is minus j theta, at that time also you will get the same thing, cos theta minus j sin theta. Then also you will get the same square root of a square plus b square, where it is a plus jb or a minus jb. Magnitude is a square plus b square only. Okay, so now magnitude we have seen. Then what is the phase angle of this one? Phase angle is nothing but the angle itself. This itself is going to be the phase angle. J followed by the term is representing the phase angle. So if you are going with e power minus j theta, this can be written as magnitude 1 with theta as the angle. Similarly, if you are going for minus j2 omega, it can be written as 1 is the magnitude and minus 2 omega as the phase angle. Okay, so magnitude of e power minus j theta or minus j2 omega is equal to 1. Using this relation, I am going to express magnitude as well as phase relationship of j omega. Okay, since it has given unity feedback, h of s is equal to 1, so g of s h of s is going to be equal to g of s itself, because it is equal to 1. Okay, so we can write the open loop transfer function g of j omega, magnitude is equal to 3 into e power minus j theta, that is nothing but 1, divided by omega into square root of omega square plus 2 square. 2 square is 4. This is magnitude. And phase angle can be written as e power j omega is equal to, okay, 3 doesn't matter, e power minus j 2 omega, that is nothing but minus 2 omega, and divided by j omega, this is nothing but a pole at origin. A pole at origin will contribute 90 degrees. Since it is in the denominator, it will be going into numerator and it will become minus pi by 2. 90 degrees minus tan inverse omega by 2. These are the phase angle equation and gain equation for the given g of j omega. Now we are going to calculate gain crossover frequency. Okay, so gain crossover frequency means at omega is equal to omega gc, that is gain crossover frequency, by that time magnitude of g of j omega, h of j omega is equal to 1. Okay, so substitute this one in the above equation. So 1 is equal to 3 divided by omega is replacing with omega gc into square root of omega gc whole square plus 4. So omega gc into square root of omega gc square plus 4 is equal to 3. Take square root on both sides, so it will be omega gc square into omega gc square plus 4 is equal to 9. So you can write it as omega g to the power of 4 minus 4 omega gc square, okay, sorry, plus 4. This is omega gc square into omega gc square, it is omega gc to the power of 4 plus 4 into omega gc square minus 9 is equal to 0. Okay, use solution for the algebraic equation ax square plus bx plus c. Then you can write it as omega gc square is equal to minus b, that is 4, plus or minus b square means 16, minus 2ab, 2 into a means 1 into b, 2a minus 4ac, sorry, minus 4 b square minus 4ac, b square minus 4ac, c means minus 9 divided by 2a, 2 into 1. So the equation is minus b plus or minus under root of b square minus 4ac. So you are going to get for this one omega gc square is equal to minus 4 plus or minus, minus into minus becomes plus, 9 into 4 is 36 plus 16. So it will be 52 divided by 2, which is nothing but minus 4 plus or minus 7.22 you will get divided by 2. And omega gc cannot be negative, so that we will choose only plus sign. Omega gc cannot be negative, so that omega gc has to be positive. For that one we are going to choose plus sign, so that plus 7.22 minus 4, that will become 3.22. So take square root, omega gc is equal to square root of 3.22, that means gain crossover frequency is equal to, okay, 3.22 divided by 2, okay, square root divided by 2, so you are going to get it as 1.26, finally 1.26 radians per second. Omega gc square root of this one, it will be 1.606 and square root of 1.606 is 1.26. Gain crossover frequency is 1.26 radians per second. Where you are getting gain crossover frequency? First one is gain crossover frequency. So this is gain crossover frequency. Only 1.26 only for D. So the option for this one is D. But still we will calculate the phase crossover frequency. Okay. Now we will calculate phase crossover frequency. Phase crossover frequency. Phase crossover frequency equation is this one. At omega is equal to omega pc or omega p, phase crossover frequency. Phase angle of g of j omega is equal to 180 degrees. So use this equation. 180 degrees is nothing but you can simply make it as 2 pi. Okay, everything must be in radians because it is asked in radians per second. So take it as 2 pi. Okay. This is 2 pi is equal to, using this equation, angle is going to be 2 pi. Sorry, angle is 180 degrees means pi only. So this is only pi. Pi is equal to 2 times of omega p minus pi by 2 minus tan inverse of omega p by 2. And if you are taking this minus pi by 2, it will become 3 pi by 2. Okay. 3 pi by 2 is equal to minus 2 omega p minus tan inverse omega p by 2. We know the expression Taylor series for the tan inverse of x. Tan inverse of x is equal to x minus x cube by 3 plus x power 5 by 5 plus x power 7 minus x power 7 divided by 7. So higher order terms we are neglecting and we will consider only the lower orders, that is nothing but x minus x cube. So you can write it as 3 pi by 2 is equal to minus 2 omega p minus, okay, x means omega p by 2 minus omega p by 2 whole cube divided by 3. So you can write it as 3 pi by 2 is equal to minus 2 omega p, okay, minus omega p by 2 minus, and to minus it will become plus, okay, plus omega p cube divided by 2 cube is 8, 8 into 3 is 24. So you are going to get this one, and after simplification, after simplification 3 pi by 2 is equal to 3 pi by 2 is equal to minus 2 omega p minus omega p by 2, that will become minus 5 omega p by 2 plus omega p cube to the power of 24, and it is approximately equal to omega p is going to be less than 1. So for that one, omega p cube is going to be very small. Omega p cube by 24 will be very small, so it will be neglected. So if you neglect this one, 3 pi by 2 can be written as minus pi by 2 itself. So this is minus omega p by 2. 2 get cancels. Omega p is equal to minus minus get cancels, pi by 5. Okay, pi by 5 means 3.14 divided by 3.14 divided by 5, which is nothing but omega p is equal to 0.63 radians. 0.63 radians per second. So the answer for this question is D itself. 1.26 radians per second is gain crossover frequency. Phase crossover frequency is 0.63 radians per second. Thank you.